decoder with enable input. Let's discuss it. So here we have this is truth table of 2 to 4 decoder, and this is circuit of 2 to 4 decoder. When our enable input is 0, our output is 0. It's mean all the LEDs are off for whatsoever inputs. Whether our input is 1, 0 or 0, 1 or 1, 1, our output is 0. Still remains 0. And when our enable input is 1, we have some output. Let's check it. Whenever both inputs are 1, the F3, it's mean the LED 4 will be below. And whenever one input, that is B, its mean S1 is 0, our LED 2 is open, it means below, that is F1. We can see from here, when S1 is 0 and S0 is 1, the 0, 1 is 1. And let's check whenever A is 0, A input is 0, the LED 3 is below. F, its mean function F2 is 1. And whenever all inputs are 0, both inputs are 0, LED 1 is below. That is function F0 is 1. The output at function F0 is 1. These are our two tasks, and let's discuss the next one, 3 to 4 decoder. Here we have our task number 3, implementation of 3 to 8 decoder with the enable input. It is the truth table of 3 to 8 decoder, and this is the circuit of 3 to 8 decoder. Let's check the truth table. This is our enable input. When our enable input is 0, our output is 0, whether our input is 1 or 0. When our enable input is 1, we have some output. Let's check the truth table. For all inputs 1, the F7 is blown up. The F7 LED is blown up. Let's check it from here. There is the F7 LED is blown up. And for when our C input is 0, when our C input is 0, the F6 is blown up. And when our B is 0 and all others are 1, the F5 is we can see that the 5 is blown up. And when A is 1, all others are 0, the F4 is blown up. We can see it from truth table here. And When B and C is 1, all other inputs A is 0 and B or C is 1. The F3 is blown up. We can see it from the truth table. Here we can see when B and C is 1 and A is 0. And when B is 1, all others are 0. The F2 is blown up. We can see it from the truth table. And for C is 1 and all others are 0. The F1 is blown up. We can see it from the truth table. Here. And when all are 0, all number inputs are 0, the F0 is blown up. You can check it from here, the truth table. So this is our task 3. Let's move on to task 4. Here we have task 4. This is a truth table and you have to make a circuit of and that truth table. Just check it. And this is our tasks 4. We have built a circuit of that truth table. Let's check it. So here we have 3 inputs A, B and C. Let's check. Whenever all inputs are 0, the output is 0. You can see that our output is 0. And when the C input is 1, the output is 1. You can see it. When the C input is 1, our output is 1. And when the B input is 1 and other all are 0, our output is 1. And when B and C are 1, we have no output. The output is 0. Sorry, we have output but it is 0. And when our A is 0, A input is 1, and others are 0. We have the output 1, the LED is blown up. And when A and C are 1, the two inputs are 1 and B is 0. Our output is 0. And when our A and B input is 1 and C is 0, our output is 0. And when all inputs are 1, we have output 1. So we have checked the truth table and it's matched with our circuit. The truth table is true. Let's move on the other. Here we have a BCD to 7 segment encoder. Let's see it. So I will discuss the tasks 5 and the task 7 at the same time, because it is same somehow. Here is our BCD to 7 segment decoder circuit. This is our whole circuit. Let's see its implementation. So now we will check our inputs and the number display. So we can see that when A, B, C and D is 0, that number displayed is 1, 0. The number display is 0. So we can see that the number displaying is 0. And when D is 1, the number displaying is 1. And when C is 1 and D is 0, the number displaying is 2. And when C and D are 1, the number displaying is 3. You can see that. And when only B is 1, all are 0. The number displaying is 4. And whenever B and D is 1, the number displaying is 5. And whenever B and C are 1, all are 0. All others are 0. The number displaying is 6. And when 3 inputs, that is B, C and D are 1, the number displaying is 7. And when all the inputs are 0 except A, the number displaying is 8. And when A and D are 1, B and C is 0, the number displaying is 9. For all inputs displaying, it is also 9. So this is our, we have discussed our 2 tasks. Let's move on to the next one. This is our task 5. Sorry, task 6. Use a medicine to construct 2 to 4 decoder. Let's discuss it. So in this task we are using multisim, and we have constructed a 2 to 4 decoder, and we have connected the inputs A and B to the data switches, and our outputs F1 F2 to the LEDs, and now we check the result. So we can see that whenever input A is 0 and B is 1, the LED3 is blown up. We have enabled input which is 1. We know that when enabled input is 0, our output is 0 for whatsoever input. And whenever both inputs are 1, the LED4 is blown up. And whenever B input is 0 and A is 1, LED2 is blown up. It is main function F1. And whenever both inputs are 0, LED1 is blown up. This is our lab 4, which I have discussed, and match all the truth tables to the circuits. Thank you.